So today we're going to talk about a little bit about input and output, and mostly in the context of text files. If you've seen the slides, it's quite a short presentation with a few simple demos, and we're going to focus on that. I'm going to give one more demonstration on top of the regular demos, just as a little more complex case about what streams can be used for. Just to take a look at that, and of course streams can be used for many things, and once we understand the purpose of streams and how they are working in the framework, you can use them to get data from anywhere to anywhere, and there are all kinds of encoding options, like the one I'm going to demonstrate, if I have the project and I didn't delete it by mistake. So we're going to talk a little bit about streams, then about reading and writing text files and some exceptions, and there are going to be a few more demonstrations to the usage of this information. So, what is a stream? It's a widely used concept not just in .NET, but in other languages as well. For example, my favorite one to talk about, C++. And the stream is a mechanism that would take data from one source to some target. So we can stream data to the screen, to the console, into or out of a file, into memory. Those are the main usages. Oh, we have guests. So you can stream your data in and out of many sources and destinations, and the most trivial one is the screen that we've seen. We can write data to the console. We can also write data to files, like we're going to see today. We can write data to memory. Those are the main three usages of streaming data, but they can be altered in many ways. In the end, the stream contains a sequence of bytes that's in the .NET implemented as a byte array. And yeah, as I've already mentioned, they could be in many sources and many destinations. For that matter, for example, if you want to dive deeper into some features of the .NET framework, I can recommend you to dig into for example, isolated storage, which is also built on streams. So, for example, isolated storage is a way of writing your data into a file, much like we're going to do today, only that it's protected for your application, for the user level, so that it's much more has much more features which are defined on the framework for it. Another example that I'm going to demonstrate today, outside the regular demos, is taking data and writing it to a file, but then streaming it also through a compressor, to a gzip compressor. So our data will be compressed and then stored into the file, and then we're going to read it back from the file and back from the file into a memory stream through the compressor to a string again, and we're going to see the data back. So just as a small demo on top of what we have. So the first thing we're going to see is why is it so bad? This is very bad. I didn't think this like that. It was. Okay, we're back. Damn hardware problems. That's why we are software ninjas, not. Okay, the first thing we're going to encounter with the streams is a StreamReader class, which it's better now. Thanks. So StreamReader, as its name implies, is used for reading a stream from some source. It's the easiest way to read a text file because it just gets the file path, and that's all we need. We can read it line for line. We can read it in sequences. We can read the whole file at once. We can specify an encoding. So if you're trying to read Cyrillic text, you can specify the encoding. So pretty much like what we know in the console, only that we are reading it from a file. So the easiest constructor is just to get it with a file name, and that's it. We have an access to the file reading. We can read it by line. We can read it all the way to the end. If we read it by line, we can reach the null. We get a null response on the read method. That means we've reached the end. And at the end, it's always a good idea to close your StreamReader so that there are no open resources or things which are left in memory and they can get lost, or, well, they can get lost. So here's a simple example. We have some file test.txt. We are constructing the StreamReader in this variable called reader. We are reading the whole file to the end. We get the content in a string. We can write it down to the console, and we're closing the stream here. Another overload of the constructor would get the file name, and we can specify an encoding. So in this case, Cyrillic alphabet. And again, closing it. However, this syntax is okay, but a much more common syntax when using streams is using the using section. So we have here an object, and many times in here, in this part of the statement inside the using, we'll have we can just define our own object, and we can call the constructor right in here, and that means that we'll have the usage of our reader in this code block, and once we are exiting this code block, we'll automatically get a closure of the stream. So that's how it's usually written. I'll show you a more complex example afterwards, and it's going to be with a few nested using statements, one inside each other. That's also valid. So you can stream your data from one stream to another. But that's basically the easiest and the most common way to wrap your stream blocks, either reading or writing. So an example of reading a file. So we have again the file name. This file name will be expected to be found next to our executing assembly. Otherwise, we can specify a full path to exactly where this file is residing. Once we have a reader, object in our hand, we are opening a using statement, and inside this block we can just call read line, and for every line we're going to just print it out with a counter that will show us the line number. And that's about it. We're finished with the code block. We're exiting and actually closing the StreamReader, and that's about it. Let's see it. That's how it started. I have to talk fast today. Okay, so if you notice, if I go to the folder where the examples are, and our first example is it's working. Our first example is the reading text file, so this is where our project is. And our executing assembly, our executable, will be created in the bin debug folder. So here it is. No, that's not it. That's actually an external executable which is related to the Visual Studio. That's the VS host here. So that's mostly related to debugging it. But if I build my project, and hopefully it will build successfully, here we have it. Now we'll have our executing assembly here. And since our file reading is by default at the same location of where our executing assembly resides, we can go back, trace back 2 directories up. That's how it's done. And we're going to read reading text file.cs. So that's actually, we're going to go back to this text file and read it as text. So we are here, and we're going up 1, 2 folders, and this is the file we're going to read. Very convenient. Once we have the file name, we're taking a StreamReader. Actually, we could have instantiated this whole statement just as it is in here, just to make it shorter, because outside of it we're not going to use the StreamReader because it's going to be closed. And we're just initializing it, instantiating it with a constructor with a file name. We're reading all the file to the end. We'll get the content in a string, and we'll just take the string and write it back to the console. Afterwards, we're going to read the file again. So we're going to create another StreamReader here, which could have been saved by the fact that we just put the statement inside the parenthesis. We're reading it again. So this time, instead of reading the file to the end, we're reading it line for line, as long as the line is not null. And in here, we are reading the next line inside to create the loop. Which reminds me, you know that a programmer, if a programmer needs to find an elephant, they're going to Africa, and they go to the lowest point, the Cape of the Good Hope, at the southmost point in Africa, and then start scanning. And every creature that they find, they can compare it to an elephant, and then they stop. But experienced programmers will always first put an elephant in Cairo, so that they will be sure that their loop will exit at some point. That's a lame joke. Okay, so that's what we have. Let's see it in action. So we're getting the file name, which is actually a relative path to the current executing assembly. Just printing the file name to the screen. And now we have our StreamReader object. We're in the using statement. I think we can also see its state.
Serious debugging.
No, I'm just browsing into all its properties, but I don't remember which one was that. In any case, let's not dig into the debugging more than needed. So here we're getting the whole file content into a string, and we can see that this string now contains the whole string, including all the line breaks. If we look here on the debugger, we'll see it just formatted nicely, which is what we'll get when we print it out to the console. So here's the content, just pour it out as it is. And now line by line, we're going to get a new StreamReader object, and we're going to use it. We're just going to start our counter, read a line, increment the counter, print, and read another line, so that every line is going to be printed in this format. And when we're finished with this loop, here we are, that's the content. I can scroll, and so that's it. I think pretty clear, right? And useful. I mean, starting to work with files is something which has a little bit of real world functionality in it, I guess. Yeah.
What kind of files we can read in this class? For example, picture, file.
In these cases, I think you would rather need to. I think that through this, I'm not sure about all the overloads, but you can. But you will have to get them as a stream of bytes first. So you yeah, if you try to read a binary file by force, we can try that actually, why not? Yeah, you can read all kinds of data with the StreamReader, and you just have to feed it with the right data, and you have to know how to parse the data that you're getting, yes. Because you'll get mostly gibberish if you try to parse binary data. But yeah, working with streams is mostly, in these cases, working with binary data is working with byte arrays, getting them into memory, and then you can parse them, do whatever you want, or write them in a file also as byte arrays, and you can encode the data in any way you want. Actually, that relates to the other example I'll show in the end of today. So that's it for reading files. Writing files, it's almost looking the same. So instead of StreamReader, we'll be using the StreamWriter. It has also a constructor that can get among its constructor overloads the file path. You can also use encoding. This false here, if I'm not mistaken, is telling whether we need to open the file and append data to it. So if the file already exists, whether we need to keep writing to it and not destroy the old information, not replace the information in the file. So this little argument here. So we have the write and the write line. Writing is actually done through a memory buffer. So first the data is written to a memory buffer on the way to the file system. And if we want to, if we have already written some data and we want to make sure that it finds its way to the file, I'll demonstrate that. We'll need to call the flush method. There is also an auto flush, which will indicate to flush it automatically upon writing. So that will make the work easier. Again, this is up to the developer to know when they want the data to be flushed to the file, when it's important to be saved, or the size of the data can matter in that case too, how much memory we're taking. So in this case, this is up to you. Again, this is the using statement. We're using the StreamWriter with the file name, and in this example we're just iterating through numbers and we're writing them to the file. Let's demonstrate it. So here's the program. Again, the file name is is relative to the path of our executing assembly. So we're going to actually create a new file there. We can see that if I go to the folder, it's not. And by the way, we can also reach the current directory, or if you need to map directories, you can use something like assembly class, which is under the reflection, system reflection namespace. We can always get the executing assembly and its location. So this will give you a full path of your currently executing assembly. That's sometimes useful, and with methods like path dot get directory name, for example, we can get the full folder name. So this statement will return the folder of the currently executing assembly if you need it for anything. In this case, we don't need to map any folders, so that we're just using a relative path. And let's see it first writing in the simple mode. So we're opening the stream, we're printing it out every line. Once the stream is closed, we'll have a print to the console, but we can already see, well, not the console, if we go to the folder, here's the file, and here's its content. So that's okay. Let's start it again. So again, we're opening the stream, and once we're doing that, we'll see that the file content is already modified, and right now it's empty because we are not appending data, we're replacing data. We'll also see that as we run through the lines, we have the stream write line, but actually the file shouldn't contain anything yet. So in order to see what we already put in the file, let me open a watch. Sorry for making you all dizzy. And I'll just use the StreamWriter flush. Once I call this method, did it write something? It should write. What am I missing? Let me put it here. This should work. Okay, the file is updated. Now on my loop I can see the previous writing, and on the next loop I flush again. It doesn't flush it really. That's a bit strange. That wasn't the case last time I checked. Something is wrong here. No, I'm getting it into focus every time. But let's see it again. So this is my file. Flush. Okay. Flush again. Something is different from the last time I tested this option. Does it have a... should have an automatic... wait, if I'll reopen it. Oh, okay, so the notepad refresh is a bit not detecting it, but okay, on the next iteration we have the next, so 5. I think maybe I used the newer version of Notepad, so now 6. So that's the idea of flushing. Okay with that?
If you close the file before flushing, it flushes automatically.
If
you open the stream, right, and then close without calling flush, it's right.
yeah, once the stream is closed, there's a flush operation. You can manually do that, or you can set it. You should be able to set the auto flush to true. And in this case, let's stop just before writing the first line, so we'll see the empty file. Now write and refresh. So that's also an option, but then you are constantly going to the file system and constantly dealing with your file, and that's performance issue. But then again, it's up to you. This gives you the tool to decide when you want to flush your data and at what point, and how much data you want to store before you flush, and how much interaction you want with the file and how much you want with the memory. Are we recording? Yeah. Just like any class in the system which is prone to errors, we have all kinds of exceptions which are can be expected in case of using streams, memories, files. So yeah, we don't need again to state what is an exception. Yeah, why is that here really? I mean, we know what exceptions are. And of course you can put a try-catch, an exception type, and you can put a finally block. Yay, we know that. So for example, when you're trying to open a file which is not really there for reading, you'll get a file not found exception, and you can handle it in any way you want. For example, write to the screen or write to a log file if you can open it. So, it's starting to get bad again. Oh no. Okay. Yeah, I mean, what we see here, you have to blink really fast, but if you do that, you will see that actually we are demonstrating three kinds of exceptions. First of all, the file not found, which is very common where you're trying to access a file which is deleted or doesn't exist. We can have a null reference exception in any case that we're trying to work with an object which is not initialized, or if it's null and we're trying to read or write its properties. And we have a general catch for any other exception, so we can handle them separately, as we all know. Yeah, let's see a small demo of that, but I think there's not much to it. So we're starting. Let's open this folder. Let me know if this shuts down, because anyone epileptic? Not anymore. Yeah, get rid of the epileptic people. That's okay. So as I checked, there is no file called. Oh man, it's getting really bad. There's no file called somefile.txt, so we might fail trying to open it. So here we are debugging. Oh, very bad. What's the time? 7. Have time for another break. I think we're going to need one. I thought this is going to be a really short day-to-day, like quickly going to files and this and that, but it's a sign from God.
Maybe the projector needs breaks. Regular breaks.
Yeah. In the old times, we used to have this guy in the back room. And he used to, whenever I made a demo, he has to change the reel and then plug all the films and change it. But it was much more reliable. Even though it used to look pretty much like this. So, but it was romantic. The students were with popcorn. So here we're going into a try-catch block, and we're trying to create a stream. And since the file is not there, we are going to end up in our catch block. Now, let's try to use a file in a non-existing folder. And again, we're going to the StreamReader, and now we're in the directory not found exception. And IO error. I don't know if we can really. Oh, okay. I think we need a break. I don't know if we can trigger an IO exception here.
Try to damage your hard drive.
Yeah.
So we can see it.
Yes.
Very educational.
It's true. Yeah, and since we're reading from a hard drive, not from some network, and since I put a lot of money into this laptop, I think we'll skip the IO exception. But we all know exceptions and how to handle them. Oh, this is really bad. Okay, I'm going to turn this off, and we're going to take another 10 or so, or as much time as this thing needs to recover. Okay, continuing before we crash again. More examples. So these examples are quite simple, and I'm glad because we've already seen what we have to see. But these examples just use everything that we've already seen in the files. So, for example, counting the words in a file. So, once we're starting to manipulate text files, we have all kinds of usable examples that we can use. One of the examples we're going to see right now is oh, we have more visitors. One of the examples we're going to see right now is something that, for example, can fix subtitle text file, because most of the subtitles for viewing movies are in text files, and personally I use an application to correct them, to fix them, to normalize them, so you can start creating your own if you really want. So another application of such text file reading and writing, for example, is getting a word count. So we can open a file and we can read the whole text, and then we can search for the index of a specific word in the text. So we know the string index of method, where we can find it, and then we can give an index to where to start the next finding. So this method will run a loop into our text, which is actually read from a file. This is nothing special, just as we've seen how to find the text in a file. The only difference is that the text origin is from a file here. So that's all there is to it. And what's wrong with this code, by the way? Yeah, we're not closing the stream, and we're not using a using statement, so that's true. Let's quickly see it. Oh no, I have to be really quick. So in this example, let's see that we have the file actually. Yeah, we have the file. Some file, is that the one? Yeah. So we have the file next to our CS file, and we're running. We are reading. We're creating a reader, initializing it with a file name. And here we're using the using statement. We're reading the file to the end, and here's the whole text of the file with all the line breaks and everything. Here it is with a proper formatting. And now we're running a counter. So we're searching. Now we have it. Now it's just regular string manipulation. Just find the text, and we're finding the index of the found me. We found an index. That's the first string in the file. So we're going to put a counter, and then so that we can know how many times, and also we're advancing the index to the next possible location after where we found the previous one, and we're finding it then in the 52nd, then 71, and 81, and so on and so forth, and we found it 5 times. So playing with files like this, you can take them. We haven't seen much of streams, of other kinds of streams, but for example, you can get your file into some kind of memory stream, or you can get it into a string and then do replacements. So you can build an application that finds and replaces text in the file, so that, for example, make it a little more usable. Second example, as I mentioned, we're all downloading movies and subtitles, and many times we have to correct the subtitle timing. So this is one option for a structure of subtitle file. It gives 2 timestamps and a string. In this case, we're opening a file with we're specifying a Cyrillic encoding in the StreamReader. We are reading and also opening a StreamWriter, so that we'll have a fixed file created for us. And actually there's not much of processing here, right? There's just reading and writing. So
There's a method fix one.
oh yeah, so it actually takes the string that it's reading, and I missed that one. It gets the fixed line and then printing it out. Yeah, there it is. So almost last live demo for today. Let's close all this and all this and go to the folder. So we have the source subtitle file, that's its content. Let's see what okay, I don't think we need to dive into the fixed line method so much, but if you want, you can see that it's actually breaking down the string and looking for those curly braces and then converting the time to an integer and then doing some processing on the time and then rebuilding the string with a fixed new time after integer processing. So that's pretty much, not much to say about that really. And here we are with the StreamReader and Writer. The encoding here I think is set to Cyrillic, but I'm not sure this is a... Yeah, this is an encoding of Cyrillic, so I don't know why it was specified, because this example file is in English, but that's okay. And actually, this one doesn't use the using statement. It's actually going to run through them in regular code blocks, and in the finally block we're going to close both of them. So we're going to read a line, and on every line we're going to create the fixed line. We can see what the fixed line will generate. Oh. So in this case you can see the line and the fixed line and see what it's producing. It's actually keeping the same, only replacing those two integers with greater numbers and printing it out. And again and again and again. And if we have some kind of exception, we have a catch block which doesn't do anything except write a message. And once we're done reading and writing, closing both streams, and we're out. So we'll see here that there's a new file, fix.sub, and we can compare. You can see that both are in order. So far, quite simple, I think. Any more questions about this? Sorry, yeah. No, they will not get automatically closed if there is some exception on the way.
Maybe that's why here they are.
Yeah. Yes, that's the reason. The reason that they are in the finally block, so that they'll always get closed once we're done running, no matter if we run into exception or not. I think this was the last slide. Yeah. So we've seen the streams a little bit, talked about it. I'm going to show one more quick example just before this projector dies again. We've seen StreamReader and Writer. We've seen how they can work with files, with text files. Well, not much to say about exceptions again. Just before that, let me show you another sample. Instead of using StreamReader and Writer, so what I have here is a long block of text. If you know lorem ipsum, is a text which means it's a gibberish text which is used usually for printing. Some people think it's some ancient Latin, but it's not. It's just some gibberish, and it's written. It's very close to Latin, and some people say that it's about the addiction to pain and suffering. Yeah. But other people will agree that it's actually meaningless, and this text is only used as sample text when in print shops and in workshops that are needing to check layouts of documents and prints. And it's become the common gibberish text to use everywhere. And you can there are several sites that can generate you any size that you want from this text, as many paragraphs as you want. So here I have a long version of it, like 6 paragraphs of this gibberish. And I'm going to create a text file. Actually, not a text file. I'm going to create a binary file here. What I'm going to do here is I'm using nested streams in this example. I have my file stream, which instead of using file writer, StreamWriter, I'm going to be using the file stream, and I'm going to let it specify the mode to create the file. And on the lower level, when I'm writing the data, I'm going to pass it through another filter that will compress it through the class gzipstream, which is part of the framework as well, that allows you to compress data. As we can see, I'm specifying the file name in the first stream, and I'm using the created file stream as an argument of the process of the gzip stream, so that they are in a way chained. And I'm specifying here the compression mode to compress the data. And I'm using this writer to actually write the text into the gzip stream, which will then direct it to the file stream. So what we have here is 2 streams, one on top of the other, and as you can see, I have 2 using statements, and they are following each other, and on the end of the first one there is no semicolon, and there are no curly braces. It's just as if you remember, when we're writing some if block, I can write something and put this, or I can put it in a curly braces block. But I can also use ifs, nested ifs like this, blah blah. So they're still nested because this if has one statement in it, which is this if, and this if has this block. So this is a common way to nest using statements, using only the lines like this, and only on the last one to open curly braces, and not to separate them with semicolons. So the production of what's going to happen here is that the text is going to stream into the text file, but first it's going to go through the gzip processing, and it will be compressed. And the second thing I'm going to do is read from the file. I'm going to use a file stream again, and I'm going to get the file with the same name, and I'm going to set it to the mode to open. That means reading the file. I'm going to create another gzip stream, and it's going to be directed to the file. And in the end, I'm going to take all the data into a memory StreamReader, and I'm going to take the data which is read from this gzip, which is, by the way, here set to decompression, into a string of text. So here we have a 3-way nested streams. I'm going to read it from the memory to from the file through the gzip to my StreamReader, And my StreamReader is going to actually get all the stream, read it to the end, and put it in a string. And in the end, I'm going to print out the file size that I've created here and the length of the original text, which was here, so we can compare the sizes. Let's hope this works. So, first thing, I'm going to go through the two using statements, and I'm going to take my text, which is 3,000 bytes, and I'm going to write it down through the gzip processing. Once I'm done with the using statements, I'm out and the file is closed. So now I can see that I have a compressed file here. Its extension is txt, but if I look into it, I'll see that it's binary gibberish. Now I'm going to use my three-way stream from the file to the gzip to the memory to the string. So I'm going to use 3 nested usings, and this is going to stream through all 3 of them in this order. And here's back my file content uncompressed. I can see it here as it was. And just for comparison, since we're using the gzip compressor, we can see the difference between the file size and the original data, which is close to half. And that's what I wanted to show. Just as a more complex demo of using streams, this is also quite useful, and usable. In many cases, when you have data that you just want to store, you can compress it and very easily store your text in a more unreadable way. And I think that's it. That's all I wanted to show today. More questions? I'm not sure. Strings can be quite big. I've never used such big strings. Usually when data is becoming very big, it's written in chunks into memory blocks, and then I've never run into a
pages and pages and fits in a string.
Yeah, in this case, actually, when we are compressing and we're using streams like this, usually we would need to supply the entire block of data that we want to compress, because the compression itself relies on the whole data, the compression algorithm. And in this case, we can't do like write line by line into the gzip writer, because this will not work. Instead, you have to take your whole chunk, write it down, push it, and it will be compressed for you. Maybe there are tricks to cut it down, but it could be tricky. I haven't tried.
So typically you want, for example, 10 pages.
Yeah, if it's text, simple text, I think it shouldn't be a problem. Strings can be long, as far as I know.
I have seen other classes like just file. What's the difference between file stream and StreamWriter and StreamReader?
I think the file class handles the file system more directly, and it has. Well, you can use file. You can also use file in a way, but streams are more flexible. in the way that you can use streams, combine streams like this. If you're just going to write text, you can use the file class, but if you need more complex things, then you'll have to use streams. And streams are more powerful, and in many cases, they are the choice to use. And the file is usually used for interacting with the file system more than memory and stream manipulation in these cases. More? Oh, seems like we have more time. Okay. In that case, I think we're done for now.